This is data types revisited. First question is, what will be the output of the following program? This is less than. So I less than 50,000. We know for if we consider the TC compiler, if it is 2 byte, then the range goes from 0 to 32767, and here 32768 negative. So this number is higher. So once it comes, this control comes here, it will go back to this number minus 32768, and this will indefinitely go on and on. So the program will get stuck up in infinite loop. Next is A is 13.5, B is 13.5. Bounce and LF, no problem, 13.5 will be shown. Now we have I equal to 0 and I equal to 0. So first of all, 0, this I will be 0. Then I plus plus, it has become 1, right? You have made it as 1. Now val, so this is 100, so 100 will be printed. Now I plus plus, this I is 100 and I is assigned value of 100, and 100 means this is 101. Now when you print it here, what will you see? This is 0, this is 100. Now 101, this will be 101, right? Because the value has changed. The only reason why the value it keeps is this is keeping the value because it is external and it will retain the value. And next time you print inside this, again because this is outside, this is inside, 100 will be again initialized. So this will be 100 here. X, Y, S equal to 2, S into is equal to 3. So S is equal to S into 3, that is 6. So we have printed S, so it will be 6. Now let us go to Y and X. Y means 6 is passed here, and here also 6 is passed. Now T is 8. So A plus is equal to minus 5 means we have passed 6. So 6 minus 5, that is 1. What is T equal to T minus 4? So T will be 8 minus 4. So T equal to T minus 4 means 8 minus 4, that is 4. Now this 4, this is 4 and this is 1. So what will we see? Next time Y, you will get 4 plus Y, 1, this is being returned. 4 plus 1 is 5. First time you get 6, this will be 5. How about X? Now you're passing 6. 6, A you are making as 1. So T equal to T plus A. A is 1 and now T is what? T has just changed. This 4, T you have changed the value. T is equal to T plus A. So T has become 4 because you have already done this. This is 4 and now you are adding T equal to T plus A. So 1 plus 4 plus 1. This will be returned. So this will be 6. So 6 will be returned. So X will be 6. Next is static int count equal to 5. So it will retain the value. %d count minus minus. And this %d means 5 will be printed first. Now count minus minus. Next is, this is 4. So 4 is not equal to 0. Main again will be called, but it will retain its value. This will be 4 now. So 4 will be printed here. 4 minus minus is 3. Again this will go on and on till 0. So 5, 4, 3, 2, 1 will come till 0. Next is Ij. I is, this is less than 5. I less than 5. We are passing I here. So let us pass 1. You'll understand others also. Just watch it carefully because next time 2 will come, 3 will come, 4. 1, 2, 3 and 4 will come. This will come. So 5 will not come. So let us see about 1. 1 will come. Static int v equal to 1. So first of all, this v is 1, x is 1 and v is 3. See, and v is equal to v plus x. So v will be equal to v plus x. That is 1 plus x. X is 1. This is v equal to v is 2 now. And v plus x plus v means 2 plus 1 plus 3. So what will be the value? 2 plus 1 plus this 2. This is 3 plus 2 plus 1, that is 6. So 6 you will get. Next time 2 will come. So next time 2 will come, this v will become, v has already become, because we have already added. So it will become 2. So next case, similarly you will add 2 with this 3 and again v equal to v plus x. So this x has to be added with 2. So you'll get 9. This is how it goes. Now x is 4.5, float y, float f, x into equal to 2.0. So x will be what? 4.5 into 2.0. This will be 9. So you are passing 9 here. This is a plus equal to 1.3. What is a? 9. This a is 9 and you are adding with 1.3. So 1.3 will be 10.3. This is x minus x is equal to 4.5. X is equal to x minus 4.5. What is x? What is x? X has become 9. So 9 minus 4.5 will be 4.5. And you are adding them. So you are adding for 10.3 with 4.5. So it will be 14.8. And this x will remain like this, 4.5, and this will remain as 14.8. So x will be 4.5 and this will be 14.8 y. I'll show you this. This is that program, similar program, and 2.0 is there, 1.3 is added, 4.5, same program. So just see the result. When you see it running, you will appreciate it. See, this is 4.5 and 14.8. So this is how the result is coming. Next is point of the error. Long num to LD. Long is presented by LD, so there is no error. Character 200, no problem. Character can go up to this, whatever the value is. Character can go up to, if this is 1 byte, it can go up to 0 to 127. But printing will have no error, so there will be no error. Unsigned A equal to 25 and long unsigned B equal to 25L. So for that A, you have to take %U. For B, you have to take %LU. So format, these two have to be exchanged. Just because This is unsigned and this is long unsigned. Next is A is this, B is 25. So long float, L float, LF, A is okay. How about B? B, this is an integer. This is for integer, not for unsigned double. For that you have to use LF percent LF. This you have to use. A is 25.345. B is pointed to this float. B is taking the address of A. So B is %U, A is %F. So this is all fine, no error. State whether the following statements are true or false. Storage for a registered storage class variable is allocated each time the control reaches the block in which it is present. This is true. This is exactly true. Most of the time we need to use automatic storage class. Yes, we use automatic storage class. True. An external storage class variable is not available to the function that precedes its function unless the variable is explicitly declared in this function. Yes. If it is not declared and it is declared after the function, then it will not be available. So it is true. Next is the value of automatic storage class variable persists between variable function invocation. Automatic, no. Only static and external. So this is false. If the CPU register are not available, the register storage class variable are treated as static storage class variable. No, this is treated as simply auto. The register storage class variable cannot hold float value. Yes, it is correct, because the sizes are different. Following program calculates the sum of digit of the number this 1, 2, 3, 4, 5. Go through it and find out why it is necessary to declare the storage class of variable sum as static. Let us see the program. So this program is actually a recursion based program. Some dig is here, some dig is here. Now what we are doing here is 1, 2, 3, 4, 5. So we have to initialize sum as 0. For that we have to use static. And then every time this recursion is called, first of all 5 will be there. So 5 will be added with 0. So 5 will be there. Next time 4 will be taken from here. So now this 4 will be taken. 4 plus 5 has to be kept in sum. So every time this sumdig function will be called, this value needs to be kept persistent. That is why we use this static, and this is the discussion also. So this is all about this chapter, question answer. Thank you so much. Take care of yourself.